Hey, have you ever feel and touched the group of symmetries ever? We are going to visualize the group of symmetries in this lecture. So, what are you waiting for? Let's get started. So, today's lesson agenda is first we shall define what is symmetric group, and we also verify the group axioms for this group. Then we'll set some examples of element composition in symmetric group. Then we shall prove this symmetric group non-abelian in general form. We shall understand the cycle notion. Then we shall prove disjoint cycles commute. We shall show that every element is a product of disjoint cycles. Then we shall know about even and odd permutation. We shall talk about the order of a cycle and elements of the group. Finally, we will solve some exercise of this topic. And finally, the bonus tip is that geometric interpretation of symmetric group.
Since school days, we have read the concept of permutation, and as we knew, a permutation is basically the rearrangement of elements. We can think every permutation as a bijective mapping from a finite set to itself. To understand the concept clearly, we may raise a question that in how many ways we can rearrange these three elements x1, x2, x3. Definitely there are 6 ways by which we can rearrange or permute the elements. And now what are we going to define a set, finite set S containing the elements. Then every permutation can be thought as a one function. For the first one, we are getting a identity function f1 from S to S. For the second, the function is f2. For the third, function is f3. For the fourth, function is f4. For the fifth permutation, the function is f5. All the permutations are from the set S to the set S itself. And for the last permutation, the function is f6.